Hello everyone, this is Shivani from Edureka, and in this tutorial we'll learn random forest. So first of all, I would like to thank all the attendees for joining this session. And just a quick one, am I audible to everyone? Alright, so Vikram says yes, Mariana says yes. Alright, so good to go. So without any further ado, let's begin this tutorial by looking at the topics that we'll be covering today. So first of all, we'll start away by getting a brief introduction of random forest, and then we'll go as to see why we actually need random forest, right? Why not anything else but actually random forest? So once we understand its need at first place, then we'll go on to learn more about what is random forest, and we'll also look at various fascinating examples of random forest so that we get a very clear understanding of it. So further, we'll also delve inside into understand the working of random forest as to how exactly random forest works. We'll also watch out the random forest algorithm step by step, right? So that you're able to write any piece of code, any domain specific algorithm on your own. Now, I personally believe that any learning is really incomplete if it's not put into application. So for its completion, we'll also implement random forest in R with a very simple use case, that is diabetes prevention. So is this agenda clear to everyone? All right. So Mariana says clear. So let's get started with the introduction then. Now, random forest is actually one of the classifiers which is used for solving classification problems. Now, since some of you might not be really aware of what classification is, so let's quickly understand classification first, and then we'll try to relate it to the random forest. So basically, classification is a machine learning technique in which you already have predefined categories under which you can classify your data. So it's nothing but a supervised learning model where you already have a data based on which you can train your machine, right? So your machine actually learns from this data. So whatever all that predefined data that you already have, it actually works as a fuel for your machine, right? So let's say for an example, ever wondered how your Gmail gets to know about the spam emails and filters it out from the rest of the genuine emails? Any guesses? All right, I'll give you a hint. Try to think something on the line that what would it actually look for? What can be the possible parameters based on which you can decide, all right, this is a genuine email or this is a spam email? So Mariana says text. That's absolutely correct, Mariana. And Vikram says subject line. All right, good. So you guys are really on the track. So there are certain parameters that your classifier will actually look for, like the subject line or the text or the HTML tags, and also the IP address of the source. From where is this mail getting from? So it will analyze all these variables and then it will classify them into the spam or the genuine folder. So let's say for an example, if your subject line states like mad or cute or pretty and some other absurd keywords, your classifier is smart enough and it's trained in such a manner that it will get to know, all right, this is a spam email, and it will automatically filter it out from your genuine emails. So that is how your classifier works basically. So that's pretty much about the classification. Now let's move forward and see what all ways can be there through which you can actually perform classification. So we have three classifiers, namely decision tree, random forest, and naive Bayes, right? So speaking briefly about decision tree at first. So decision tree actually splits your entire data set in the structure of a tree, and it makes decision at every node and hence called decision tree. So no Big Bang theory, right? So you have certain data set, there are certain nodes. At each node, it will further split into the child nodes, and at each node, it will make a decision. So final decision will be in the form of positive and negative, right? So let's say, for an example, you want to purchase a car. right? So what all will be the parameters? Let's say I go and I want to purchase a car, then I will keep certain parameters in my mind. That would be what exactly is my income, what is my budget, what is the particular brand that I want to go for, what is the mileage of the car, what is the cylinder capacity of the car, and so on and so forth, right? So I'll make my decision based on all these parameters, right? And that is how you make decisions. And further, if you really want to know more about decision tree as to how it exactly works, you can also check out our decision tree tutorial as well. So let's begin now to the random forest now. So random forest is an ensemble classifier actually. Now let's understand what this word ensemble means. So ensemble methods actually use multiple machine learning algorithms to obtain better predictive performance. So particularly talking about random forest, so random forest uses multiple decision trees for prediction, right? So you are ensembling a lot of decision trees to come up to your final outcome. As you can also look here in the image, that your entire data set is actually further split into 3 subsets, right? And each subset further leads to a particular decision tree. So here you have 3 decision trees, and each decision tree will lead to a certain outcome. Now what random forest will do is it will compile the results from all the decision trees, and then it will lead to a final outcome, right? So it's compilation of all the multiple decision trees. That's all about the random forest. Now let's see what lies there in naive Bayes, right? So naive Bayes is a very famous classifier which is made on a very famous rule called Bayes theorem. You might have studied about naive Bayes theorem in your 10th standard as well. So let's just see what Bayes theorem describes. So Bayes theorem actually describes the probability of an event based on certain prior knowledge of conditions that might be related to the event, right? So for example, if cancer is related to age, right? So then person's age can be used to more accurately assess probability of having a cancer than without having the knowledge of age. So if you know the age, then it will become handy in predicting the occurrence of cancer for a particular person, right? So the outcome of first event here is actually affecting your final outcome, isn't it? Yeah. So this is how naive Bayes classifier actually works. So that was all to give an overview of naive Bayes classifier. And this is all pretty much about the types of classifiers. So any doubts so far? All right. So Mariana says no doubts. That's good. So let's move ahead then, Mariana. Now we'll try to find out the answer to this particular question as to why we need random forest. Fine. So like human beings learn from their past experiences. So unlike human beings, a computer does not have experiences. Then how does machine takes decisions? Where does it learn from? Well, a computer system actually learns from the data, which represents some past experiences of an application domain. So now let's see how random forest helps in building up the learning model with a very simple use case of credit risk detection. Now, needless to say that credit card companies have a very vested interest in identifying financial transactions that are illegitimate and criminal in nature. And also I would like to mention this point that according to the Federal Reserve Payments Study, Americans used credit cards to pay for 26.2 billion purchases in 2012. And the estimated loss due to unauthorized transactions that year was US $6.1 billion. Now, in the banking industry, measuring risk is very critical because the stakes are too high. So the overall goal is actually to figure out who all can be fraudulent before too much financial damage has been done. So for this, a credit card company receives thousands of applications for new cards, and each application contains information about an applicant, right? So here as you can see that from all those applications, what we can actually figure out is our predictive variables, like what is the marital status of that person, what is the gender of the person, what is the age of the person, and the status, which is actually whether it is a default payer or a non-default payer. So default payments are basically when payments are not made in time and according to the agreement signed by the cardholder. So now that account is actually said to be in the default. So you can easily figure out the history of the particular cardholder from this. Then we can also look at the time of payment, whether he has been a regular payer or a non-regular one, what is the source of income for that particular person, and so forth. So to minimize loss, the bank actually needs certain decision rule to predict whether to approve a particular loan of that particular person or not. Now here is where the random forest actually comes into the picture, right? Now let's see how random forest can actually help us in this particular scenario. Now we have taken randomly two parameters out of all the predictive variables that we saw previously. Now we have taken two predictive variables here. The first one is the income and the second one is the age, right? And similarly, parallelly, two decision trees have been implemented upon those predicted variables. Now let's first assume the case of the income variable, right? So here we have divided our income into three categories. The first one being the person earning over $35,000, second from $15,000 to $35,000, the third one earning in the range of $0 to $15,000. Now, if a person is earning over $35,000, which is a pretty good income, pretty decent, so now we'll check out for the credit history. Now here the probability is that if a person is earning a good amount, then there is very low risk that he won't be able to pay back. Already earning good, so the probability is that his application of loan will get approved, right? So there is actually low risk or moderate risk, but there's no real issue of high risk as such. We can approve the applicant's request here. Now let's move on and watch out for the second category where the person is actually earning from $15,000 to $35,000, right? Now here the person may or may not pay back. So in such scenarios, we'll look for the credit history as to what has been his previous history. Now, if his previous history has been bad, like he has been a defaulter in the previous transactions, we'll definitely not consider approving his request and he'll be at the high risk end, which is not good for the bank. If the previous history of that particular applicant is really good, then we will, just to clarify our doubt, we'll consider another parameter as well, that will be our debt. Now, if he's already in really high debt, then the risks again increases and there are chances that he might not repay in the future. So here we'll not accept the request of the person having high debt. If the person is in the low debt and he has been a good payer in his past history, then there are chances that he might pay back and we can consider approving the request of this particular applicant. Now let's look at the third category, which is a person earning from $0 to $15,000. Now this is something which actually raises the eyebrow, and this person will actually lie in the category of high risk. All right, so the probability is that his application of loan will probably get rejected. Now we'll get one final outcome from this income parameter, right? Now let us look at our second variable, that is age, which will lead into the second decision tree. Now let us say if the person is young, right? So now we'll look forward to if it is a student. Now, if it is a student, then the chances are high that he won't be able to repay back because he has no earning source, right? So here the risks are too high and the probability is that his application of loan will get rejected. Fine. Now, if the person is young and he's not a student, then we'll probably go on and look for another variable, that is bank balance. Now let's look if the bank balance is less than 5 lakhs. So again, the risk arises and the probability is that his application of loan will get rejected. Now, if the person is young, is not a student, and he has a bank balance of greater than 5 lakhs, he's got a pretty good and stable bank balance, then the probability is that his loan of application will get approved of. Now let us take another scenario. If he's a senior, right? So if he's a senior, we'll probably go and check out for his credit history. How well has he been in his previous transactions? What kind of a person he's like, whether he's a defaulter or he's a non-defaulter. Now, if he's a very fair kind of person in his previous transactions, then again the risk arises and the probability of his application getting rejected actually increases, right? Now, if he has been an excellent person as per his transactions in the previous history, so now again here there is least risk and the probability is that his application of loan will get approved. So now here these two variables, income and age, have led to two different decision trees, right? And these two different decision trees actually led to two different results. Now what Random Forest does is it will actually compile these two different results from these two different decision trees, and then finally it will lead to a final outcome. That is how Random Forest actually works, right? So that is actually the motive of the Random Forest. Now let us move forward and see what is Random Forest, right? You can get an idea of the mechanism from the name itself, Random Forest. So a collection of trees is a forest, that's why called forest probably. And here also the trees are actually because being trained on subsets which are being selected at random, and therefore they're called random forests. So a random forest is a collection or an ensemble of decision trees, right? Here, a decision tree is actually built using the whole data set considering all features. But actually in random forest, only a fraction of the number of rows is selected, and that too at random, and a particular number of features which are actually selected at random are trained upon, and that is how the decision trees are built upon, right? So similarly, a number of decision trees will be grown and each decision tree will result into a certain final outcome, and random forest will do nothing but actually just compile the results of all those decision trees to bring out the final result. As you can see in this particular figure, that a particular instance actually has resulted into three different decision trees, right? So now tree 1 results into a final outcome called class A, and tree 2 results into class B. Similarly, tree 3 results into class B. So random forest will compile the results of all these decision trees and it will go by the call of the majority voting. Now since here two decision trees have actually voted into the favor of the class B, that is decision tree 2 and 3, therefore the final outcome will be in the favor of the class B. And that is how random forest actually works upon. Now, one really beautiful thing about this particular algorithm is that it is one of the versatile algorithms which is capable of performing both regression as well as classification. All right, so Vikram has a doubt in this. Vikram has asked a question, what is regression? All right, Vikram. So, like classification basically deals by classifying a certain data set into two different classes, right? It results into the answer in terms of yes or no, approved or not approved. Fine. Whereas regression is actually the problem where you actually find out the relationship between the independent and dependent variables. Now here independent variables are your predictor variables, and your dependent variable is your target variable which you actually intend to find out, right? So once you have actually figured out that relationship between your predictor variables and your target variables, then you train your entire model upon that particular relationship, and that is how you can predict any of the new situation that arises based on your past experiences that you have learned on your previous relationship, right? That is how regression works. And random forest is one such algorithm which works well for both of them, regression as well as classification, with almost the same sort of accuracy and efficiency. So that is the beauty of random forest actually. Was I able to answer your question, Vikram? All right, Vikram says yes. So that's good. So then let's move ahead. Now let's try to understand random forest further with a very beautiful example. All right, this is my favorite one. So let's say you want to decide if you want to watch Edge of Tomorrow or not, right? So in this particular scenario, you will have two different actions to work upon. Either you can just straight away go to your best friend, ask him about, all right, whether should I go for Edge of Tomorrow or not? Will I like this movie? Or you can ask a bunch of friends and take their opinion in consideration, and then based on the final result, you can go out and watch Edge of Tomorrow, right? So now let's just take the first scenario. So where you go to your best friend, ask about whether you should go out to watch Edge of Tomorrow or not. So your friend will probably ask you certain questions, like the first one being here, genre. So let's say your friend asks you if you really like the adventurous kind of movies or not. So you say, yes, definitely, I would love to watch adventure kind of movie. So the probability is that you will like Edge of Tomorrow as well, since Edge of Tomorrow is also a movie of adventure and sci-fi kind of genre, right? So let's say you do not like the adventure genre movie. So then again, the probability reduces that you might really not like Edge of Tomorrow, right? So from here, you can come to a certain conclusion, right? Let's say your best friend puts you into another situation where he'll ask you, all right, do you like Emily Blunt? And you say, definitely I like Emily Blunt. And then he puts another question to you. Do you like Emily Blunt to be in the main lead? And you say, yes. Then again, the probability arises that you will definitely like Edge of Tomorrow as well. Because Edge of Tomorrow has the Emily Blunt in the main lead cast. So, and if you say, oh, I do not like Emily Blunt, then again, the probability reduces that you would like Edge of Tomorrow too, right? So this is one way where you have one decision tree and your final outcome, your final decision will be based on your one decision tree, or you can say your final outcome will be based on just one friend. Now, definitely, you're not really convinced. You want to consider the options of your other friends also, so that you can make very precise and crisp decision, right? You go out and you approach some other bunch of friends of yours. So now let's say you go to 3 of your friends and you ask them the same question, whether I would like to watch Edge of Tomorrow or not. So you go to and approach 3 of your friends, friend 1, friend 2, and friend 3. Now you will consider each of theirs vote, and then your decision now will be dependent on the compiled results of all of your 3 friends, right? Now here, let's say you go to your first friend and you ask him whether you would like to watch Edge of Tomorrow or not. And your first friend puts you to one question. Did you like Top Gun? And you say, yes, definitely, I did like the movie Top Gun. Then the probability is that you would like Edge of Tomorrow as well, because Top Gun is actually a military action drama, which also Tom Cruise. So now again, the probability arises that yes, you will like Edge of Tomorrow as well. And if you say, no, I didn't like Top Gun, then again, the chances are that you wouldn't like Edge of Tomorrow, right? Then another question that he puts you across is that, do you really like to watch action movies? And you say, yes, I would love to watch them. Then again, the chances are that you would like to watch Edge of Tomorrow. So from your friend one, you can come to one conclusion. Now here, since the ratio of liking the movie to don't like is actually 2:1, so the final result is actually you would like Edge of Tomorrow. Now you go to your second friend and you ask the same question. So now your second friend asks you, did you like Far and Away when we went out and the last time when we watched it? And you say, no, I really didn't like Far and Away. Then you would say, then you are definitely going to like Edge of Tomorrow. Why it is so? Because Far and Away is actually, since most of you might not be knowing it, so Far and Away is genre of romance, and it revolves around a girl and a guy falling in love with each other and so on. So the probability is that you wouldn't like Edge of Tomorrow. So he asks you another question. Did you like Oblivion? And do you really like to watch Tom Cruise? And you say yes. And again, the probability is that you would like to watch Edge of Tomorrow. Now, why? Because Oblivion again is a science fiction casting Tom Cruise, full of strange experiences and where Tom Cruise is the savior of the mankind. Well, that is the same kind of plot in Edge of Tomorrow as well. So here it is pure yes that you would like to watch Edge of Tomorrow. So you get another second decision from your second friend. Now you go to your third friend and ask him. So probably your third friend is not really interested in having any sort of conversation with you. So it just simply asks you, did you like Godzilla? And you say, no, I didn't like Godzilla. So you say, definitely you wouldn't like Edge of Tomorrow. Why so? Because Godzilla is also actually a science fiction movie from the adventure genre. So now you've got three results from three different decision trees from three different friends. Now you compile the results of all those friends and then you make a final call that yes, would you like to watch Edge of Tomorrow or not? So this is some very real time and very interesting example where you can actually implement random forest into ground reality, right? Any questions so far? No, that's good. And then we can move forward. Now let us look at various domains where random forest is actually used. So because of its diversity, random forest is actually used in various diverse domains, right? So be it banking, be it medicine, be it land use, be it marketing, name it and random forest is there. So in banking particularly, random forest is being actually used to make it out whether the applicant will be a defaulter pair or it will be non-defaulter one, so that it can accordingly approve or reject the applications of loan, right? So that is how random forest is being used in banking. Talking about medicine, random forest is widely used in medicine field to predict beforehand what is the probability if a person will actually have a particular disease or not, right? So it's actually used to look at the various disease trends. Let's say you want to figure out what is the probability that a person will have diabetes or not, and so what would you do? You'll probably look at the medical history of the patient, and then you will see, all right, this has been the glucose concentration, what was the BMI, what was the insulin levels in the patient in the past previous 3 months, what is the age of this particular person, and you will make different decision trees based on each one of these predicted variables, and then you will finally compile the results of all those variables, and then you will make a final decision as to whether the person will have diabetes in the near future or not. That is how random forest will be used in medicine sector. Now, random forest is also actually used to find out the land use. For example, I want to set up a particular industry in certain area. So what would I probably look for? I look for what is the vegetation over there, what is the urban population over there, right? And how much is the distance from the nearest modes of transport, like from the bus station or the railway station. And accordingly, I will split my parameters and I will make decision on each one of these parameters. And finally, I'll compile my decision of all these parameters, and that will be my final outcome. So that is how I'm finally going to predict whether I should put my industry at this particular location or not, right? So these three examples have actually been majorly around classification problem, because we are trying to classify whether or not. We're actually trying to answer this question, whether or not, right? Now let's move forward and look how marketing is revolving around random forest. So particularly in marketing, we try to identify the customer churn. So this is particularly the regression kind of problem, right? Now how, let's see. So customer churn is nothing but actually the number of people which are actually, or the number of customers who are losing out. So who are going out of your market. Now you want to identify what will be your customer churn in near future. So most of the e-commerce industries are actually using this, like Amazon, Flipkart, etc. So they particularly look at your each behavior as to what has been your past history, what has been your purchasing history, what do you like based on your activity around certain things, around certain ads, around certain discounts, or around certain kind of materials, right? If you like a particular top, your activity will be more around that particular top. So that is how They track each and every particular move of yours, and then they try to predict whether you will be moving out or not. So that is how they identify the customer churn. So these all are various domains where random forest is used. And this is not the only list. So there are numerous other examples which actually are using random forests. That makes it so special actually. Now let's move forward and see how random forest actually works. Right? So let us start with the random forest algorithm first. Let's just see it step by step as to how random forest algorithm works. So the first step is to actually select certain M features from T where M is less than T. So here T is the total number of the predictor variables that you have in your data set. And out of those total predictor variables, you will select some randomly, some few features out of those. Now, why we are actually selecting a few features only? The reason is that if you will select all the predictive variables or the total predictor variables, then each of your decision tree will be same. So your model is not actually learning something new. It is learning the same previous thing because all those decision trees will be similar, right? Now, if you actually split your predicted variables and you select randomly a few predicted variables only, let's say there are 14 total number of variables, and out of those you randomly pick just 3, right? So every time you will get a new decision tree. So there will be variety, right? So the classification model will be actually much more intelligent than the previous one. Now it has got varied experiences, so definitely it will make different decisions each time. And then when you will compile all those different decisions, it will be a new, more accurate and efficient result, right? So the first important step is to select certain number of features out of all the features. Now let's move on to the second step. Let's say for any node D. Now the first step is to calculate the best split at that point. So you know that decision tree, how decision tree is actually implemented. So you pick up the most significant variable, right? And then you will split that particular node into further child nodes. That is how the split takes place, right? So you will do it for M number of variables that you have selected. Let's say you have selected 3, so you will implement the split at all those 3 nodes in one particular decision tree, right? The third step is split of the node into 2 daughter nodes. So now you can split your root node into as many nodes as you want to, but here we'll split our node into 2 daughter nodes as to this or that. So it will be an answer in terms of this or that, fine. Our fourth step will be to repeat all these 3 steps that we've done previously, and we'll repeat all this splitting until we have reached all the n number of nodes, right? So we need to repeat until we have reached till the leaf nodes of our decision tree. That is how we will do it, right? Now, after these 4 steps, we will have our one decision tree. But random forest is actually about multiple decision trees. So here our 5th step will come into the picture, which will actually repeat all these previous steps for D number of times. Now here D is the D number of decision trees. Let's say I want to implement 5 decision trees. So my 5th step will be to implement all the previous steps 5 times. So here the iteration is for 5 number of times, right? Now, once I have created these 5 decision trees, still my task is not complete yet. Now, my final task will be to compile the results of all these 5 different decision trees, and I will make a call on the majority voting, right? Here, as you can see in this picture, I had n different instances. Then I created n different decision trees. And finally, I will compile the result of all these n different decision trees, and I'll take my call on the majority voting, right? So whatever my majority vote says, that will be my final result. So this is basically an overview of the random forest algorithm, how it actually works. Let's just have a look at this example to get much better understanding of what we have learned. So let's say I have this data set which consists of 4 different instances, right? So basically it consists of the weather information of previous 14 days, right? From D1 till D14. And this basically outlook, humidity and wind, this basically gives me the weather condition of those 14 days. And finally, I have play, which is my target variable, whether match did take place on that particular day or not, right? Now, my main goal is to find out whether the match will actually take place if I have following these weather conditions with me on any particular day. Let's say if the outlook is rainy that day and humidity is high and the wind is very weak. So now I need to predict whether I will be able to play the match that day or not. All right. So this is a problem statement. Fine. Now let's see how random forest is used in this to sort it out. Now here the first step is to actually split my entire data set into subsets. Here I have split my entire 14 variables into further smaller subsets, right? Now these subsets may or may not overlap, like there is certain overlapping between D1 till D3 and D3 till D6, fine? So there is an overlapping of D3. So it might happen that there might be overlapping. So you need not really worry about the overlapping. But you have to make sure that all those subsets are actually different, right? So here I have taken 3 different subsets. My first subset consists of D1 till D3. My second subset consists of D3 till D6. And my third subset consists of D7 till D now. Now I will first be focusing on my first subset. Now here let's say that particular day the outlook was overcast. Fine. If yes, it was overcast, then the probability is that the match will take place. So overcast is basically when your weather is too cloudy. So if that is the condition, then definitely the match will take place. Now let's say it wasn't overcast, then you will consider the second most probable option, that will be the wind, and you will make your decision based on this now. Whether wind was weak or strong. If wind was weak, then you will definitely go out and play the match, else you would not. So now the final outcome out of this decision tree will be play, because here the ratio between the play and no play is 2:1. So we get to a certain decision from a first decision tree. Now let us look at the second subset. Now since second subset has different number of variables, so that is why this decision tree is absolutely different from what we saw in our first subset. So let's say if it was overcast, then you will play the match. If it isn't the overcast, then you would go and look out for humidity. Now further, it will get split into 2, whether it was high or normal. Now we'll take the first case. If the humidity was high and wind was weak, then you will play the match. Else, if humidity was high but wind was too strong, then you would not go out and play the match, right? Now let us look at the second daughter node of humidity. If the humidity was normal and the wind was weak, then you will definitely go out and play the match, else you won't go out and play the match. So here, if you look at the final result, then the ratio of plays to no play is 3:2. Then again, the final outcome is actually play, right? So from second subset, we get the final decision of play. Now let us look at our third subset, which consists of D7 till D9. Here, if again the overcast is yes, then you will play a match, else you will go and check out for humidity. And if the humidity is really high, then you won't play the match, else you will play the match. Again, the probability of playing the match is yes, because the ratio of no play is 2:1, right? So 3 different subsets, 3 different decision trees, 3 different outcomes, and 1 final outcome after compiling all the results from these 3 different decision trees. All right. So I hope this gives a better perspective, a better understanding of random forest, like how it really works. Any questions, please let me know. Good. So no questions. All right. So now let's just have a look at various features of random forest, right? So the first and the foremost feature is that it is one of the most accurate learning algorithms, right? So why it is so? Because single decision trees are actually prone to having high variance or high bias. And on the contrary, actually random forests, it averages the entire variance across the decision trees. So let's say if the variance is, say, X for decision tree. But for random forest, let's say we have implemented n number of decision trees parallelly. So my entire variance gets averaged upon, and my final variance actually becomes x upon n. So that is how the entire variance actually goes down as compared to other algorithms, right? Now, second most important feature is that it works well for both classification and regression problems. And by far, I have come across this is one and the only algorithm which works equally well for both of them, be it classification kind of problem or a regression kind of problem, right? Then it really runs efficient on large databases. So basically, it's really scalable. Even if you work for the lesser amount of database, or if you work for a really huge volume of data, right? So that's a very good part about it. Then the fourth most important point is that it requires almost no input preparation. Now, why am I saying this is because it has got certain implicit methods which actually take care and remove all the outliers and all the missing data, and you really don't have to take care about all that thing while you are in the stages of input preparation. So Random Forest is all here to take care of everything else. And next is it performs implicit feature selection. Right. So while we are implementing multiple decision trees, so it has got implicit method which will automatically pick up some random features out of all your parameters, and then it will go on and implementing different decision trees. So for example, if you just give one simple command that, all right, I want to implement 500 decision trees, no matter how, so Random Forest will automatically take care and it will implement all those 500 decision trees, and those all 500 decision trees will be different from each other. And this is because it has got implicit methods which will automatically collect different parameters itself out of all the variables that you have, right? Then it can be easily grown in parallel. Why it is so? Because we are actually implementing multiple decision trees, and all those decision trees are running, or all those decisions trees are actually getting implemented parallelly. So if you say I want 1,000 trees to be implemented, so all those 1,000 trees are getting implemented parallelly. So that is how the computation time reduces down, right? And the last point is that it has got methods for balancing error in unbalanced data sets. Now, what exactly unbalanced data sets are? Let me just give you an example of that. So let's say you're working on a data set, fine, and you create a random forest model and get 90% accuracy immediately. Fantastic, you think, right? So now you start diving deep, you go a little deeper, and you discover that 90% of that data actually belongs to just one class. Damn, now your entire data set, your entire decision is actually biased to just one particular class. So Random Forest actually takes care of this thing, and it is really not biased towards any particular decision tree or any particular variable or any class. So it has got methods which looks after it, and they does all the balance of errors in your data sets. So that's pretty much about the features of Random Forest. Any questions? All right, so let's move forward and see the demo part. Let me take you over how we can implement whatever we have learned until now in R, right? So let's see. All right, so we have a situation here where a doctor wants to actually predict the occurrence of diabetes beforehand so that any appropriate preventive measures, whatever so be, can be taken beforehand itself, right? So now let's see how data scientists can actually help in predicting the occurrence of diabetes by making use of random forest, right? Now the first and the foremost part while implementing any sort of algorithm is the data acquisition, right? So here in this particular case, the medical history of the patient actually becomes the data which can be actually trained upon. So for example, so here we have a few predictor variables as to glucose concentration, what would be the blood pressure of the patient, what would be the skin fold thickness of the patient, what are the insulin levels, what is the BMI, the pedigree function, age. So these all will be our predictor variables based upon which our system will actually learn, right? And this is diabetic is actually the target variable, where yes means the person actually had diabetes, under all these certain conditions, and no means the person did not have diabetes under such number of conditions. So this is basically expressing the past experience of a number of patients, and we'll feed this data into our system and we'll implement random forest on this data, and after that our model will actually be able to predict any new instance that might happen depending on any patient, and then it will predict what is the probability of having diabetes for that particular patient in future or not, right? So that is our main goal. Now our next step will be actually to divide our entire data set into two parts. The first one will be the training data set and the second one will be the testing data set. Now why we have actually split our entire data set into two parts, it's because the first training data set will be to actually train our model. So this is the data set which is actually going inside to the model, and random forest will be actually implemented on a training data set. Now to know how good a model is, to validate how good a model is, what are the differences between the predicted and the actual values, so that we can actually get to know the accuracy and efficiency of our model, we need to test upon our data set upon, right? We need certain data over which we can actually test our model. So that is why we have testing data set, which is actually to validate and make predictions. Now for this, what we've done is, firstly, we have loaded our data set, that is diabetes.csv, in the CSV format into R, right? To have a very broader view of our data set, we have used another command, view, right? And the next step to divide the data set we have taken is, we've used sample function, and we have divided our entire data set here in the ratio of 0.7:0.3, which actually means that 70% of our data set will be actually training data set, and the remaining 30% of the data set will be our testing data set, right? So this is how we have split our data set into two parts. Now here what we have done is, we have passed our training data set into another variable, diabetrain, and similarly we have passed our testing data set into another variable called diabetest. Now onwards we will be using diabetrain for training purposes and diabetest for testing purposes, right? So let's just have a quick view how we can implement these things in R, and how does it actually look at our workplace, right? So this is my workplace, this is R Studio. I have a script which is in R, written in R. So now let's implement all the things one by one. Let's first load our data set into R. And let's view how does our data set look like. So as you can see here, that these all are my variables. So this is how our workspace would look like. This is our studio. So let's just get started. Let's first load our data set into our system. Diabet read.csv and the file name, that is diabetes.csv, in the CSV format. And now let's just have a quick look at our data set, right? So this is how our entire data set would look like. Glucose concentration, blood pressure, diabetes, pedigree function, BMI. All these are our predictor variables, and is diabetic is our target variable, right? This is what we are supposed to have. And here we have, it shows that there are 768 entries. So this is the data collected from actually 768 different person, right? Now let's move forward and split our entire data set into two parts, training as well as testing data set. So I'll just split it into two, set.c2. Further, I will give a new name, ID. Sample, this is the function used to split the data. My data set is actually diabetes, so I'm going to split that into the ratio of 70:30. So for that I've used this function prop. and 0.7, 0.3. Now I will feed in my entire training data set into a new variable, diabet train, right? Nothing, just putting the ID that I've given earlier. So all the predictive variables having the ID equals to 1 will be actually fed into diabet train, and in different new data set with ID equals to 2 will actually be fed into diabet test. Alright, so until now we have loaded the dataset into in our RStudio, we have split the dataset. So now let's move forward and see how to implement the model, right? So further, now here we have used tuneRF function to actually find out the optimized value of M. Since I've already discussed it, that when you implement multiple decision trees in random forest, you do not actually take all of the predictor variables, because if you will take all the predictor variables, then all of your decision trees will be actually similar. So your machine is actually not learning anything new from those multiple decision trees, since all those decision trees will be similar. So for having variety in your decision trees, you need to have smaller number of predictor variables out of all the total number of predictor variables. Let's say you have right now 7 or 8 predictor variables in this particular case, and out of that you choose, let's say, 3. So when you randomly pick up only 3 variables and you implement 500 trees, those all trees will be very different from each other, right? So to bring that variety and to bring more efficiency and accuracy, we have taken this tuneRF function so that we can get the optimized number of those random variables that we need to choose. So for that we have used tuneRF function. The first parameter is the diabet train, because we will be actually implementing our random forest model on diabet train itself. Then I have supplied it with my target variable, that is diabetic, right? Further, the third parameter is the step factor. So there will be number of iterations to reach to that particular optimized level where the number of predictor variables will be optimized. So for that I've chosen step factor equals to 1.2. So every iteration the factor actually increases by 1.2, right? Now another fourth important parameter is improve, which is 0.01. So now it will keep on iterating, so there has to be a certain end, right? So otherwise it will actually get caught up in the loop. To end that iteration, to end that loop, we have an improvement factor of 0.01. So if there is an improvement of 0.01 from your previous iteration, then the iteration will go on, else the iteration will stop then and there only, and whatever be the value of M, that will be your final value of M. That will be the most optimized value of the random variables that you will be going to pick. Further, we have kept the trace and plot equals to T, that is true. So because we are going to plot this, that is why we have kept it to true, right? Nothing much. Now let's move forward and see how to implement the random forest model. For that, we have actually loaded our random forest library into the system, and further we have fed the random forest function with the target variable and tilde dot. So here dot means all the predictor variables. So please don't get confused with that we are taking all the predictor variables. So random forest inbuilt has functions. It has got inbuilt methods which will take care of selecting certain random variables out of all the predictor variables. So here you have to supply it with all the predictor variables. It has got inbuilt methods. So it will pick up randomly from those predictor variables only. So please don't get confused here. Since we will be implementing our model on the training dataset, that's why we have supplied here the diabet train. Now to see what our implemented model had to present us, we have implemented diabet forest. So this will give us the entire summary of the model. Further, now while implementing decision trees actually split at the most significant variable, right? So our root node will be actually the most significant variable of all the predictor variables, right? and further the split actually gradually takes place according to the significance of the variables only. So to get an overview of the significance of all the variables, we have used this importance parameter here. So it will give us the entire list of all the variables. So now just let us see what does it look like in our RStudio. Let's just implement them in RStudio now. So now let's move forward and see how we would implement the random forest model on our training dataset, right? So firstly, we need to install the package random forest. It will take some time. All right, done. So now we'll load this into our system, this package. Now, see, since one of our target variables is actually in the format of yes or no, and the rest of our predictive variables are in the format of numeric form. So here, to bring that consistency, we'll actually convert our target variable into the factor form, right? So that is why now I'm going to actually convert my target variable is diabetic into the factor form using my function as dot factor and my target variable again. So now my is diabetic, my target variable has been overwritten. So I am converting it into the factor form and again just putting it back into the is diabetic only. So the same name, that is why. And similarly, I'll do for my training data set, that is diabet train. So I'll just change it here, certain change here, diabet train. The best part about it is that you need not write everything again and again, so it's very smart enough and it gives you the suggestions. So I just really like this thing about it. Now done. Now let's move forward. Now I'll use my tuneRF function here to find out the optimized value of my M, that is random variables that I'll be choosing. TuneRF, giving it my training data set. Then my step factor equals to 1.2, improve equals to 0.01, trace equals to t, plot equals to t. That's it. All right. So here you can see that the most optimized value of the number of random variables is 3, corresponding to OOB. That is 0. So OOB it's nothing but actually the prediction error. That is how much different are your predicted variables from the actual variables, right? So here OOB is 0%. That's pretty good. So let's move ahead and random forest. I guess I have loaded it earlier. Anyways, so diabetes. Now I'm actually going to implement my random forest model over here and putting the output into one variable called diabet forest. The entire predictor variables, that's why I've put dot over there. Now let's see what is the summary of my model. All right. So now just let's have a quick view at the output. So here the type of random forest is classification. Since I've already talked about that the random forest can actually work upon two kinds of problems, classification as well as regression sort of problem. But since we are actually classifying our output into two, that is whether the diabetes will occur or not, right? Since we're classifying our patients into two categories of one having the diabetes and one not having the diabetes, that is why it is a classification kind of problem. For this, we have implemented 500 number of trees, 500 multiple trees, and our final result will be actually based on the compilation of the outcomes of all those 500 different decision trees, right? Now, the number of variables chosen at each split is 2. What does this mean? That at each node in your decision tree, every node will actually split into two daughter nodes. That is what it's trying to say. Now the OOB estimate of error rate is actually 26.5%, which is pretty decent. That's fair enough. Now let's see why this 26.5% has actually occurred, right? So here this confusion matrix which will actually provide me the difference between the predictor variables and the prediction and the actual values. Let's see how. So can you look at this 2294 figure? All right. So here it means that the probability of having the diabetes was no. It means there were 294 patients who did not have diabetes. This was what was predicted as well as the actual one. So actual was 294 and 290 and the predicted ones were 294. So there is no gap, right? This is a good one. Similarly, for 97 were such values which had diabetes. So this is what was actual and this one was predicted. Fair enough. Now, if you look diagonally, so if you look here, 87 and this 54, right? So there were 87 such values which were predicted wrong because actually they had diabetes, but we predicted it to be non-diabetic person. Similarly, there were 54 values as such, right, which were predicted, all right, that the person had the diabetes, but actually they did not have diabetes. These diagonal values are giving you the clear justification of why we had the OOB estimate error of 26.5% because there was the gap, all right. Now to get a very fair view of the significance of the variables, let us implement our importance parameter. Importance, and I'll feed in diabet forest. Here you can see that the glucose concentration has the maximum value, right? That's 56.63. And since it is the maximum value, it will be the most significant variable in our decision tree. The second most significant variable as per the value will be BMI. That will be 39.16. So here you can get a very fair judgment as to how our decision trees can be built, what will be the significance of all the variables, and where this split should actually take place at the time, right? Also, if you want to have a clear view of this, we can also plot it using where implot function and feeding it with diabet forest. So this is how my plot is going to look like, right? As per the plot also, glucose concentration has got the maximum value. See, visualization makes things more clear and better. So it's always good to visualize whatever you are doing, whatever you are implementing. So it gives a very fair idea, right? Now let's move forward. Now, once we have implemented our model, now it's also important to validate our model, right? So for that, we'll be using predict function. All right, so now let us see how to make the predictions. Let us say we have any variable pred1 diabet where in which I'll be feeding my output. Then I'll make use of predict function, the output of my model, then my testing data set, that is diabet test, because I'll be testing on my test data set only. Type equals to class. So here you can see that all these are my predicted outputs, right? So corresponding to, say, let's say second person, fine. So second person did not have diabetes. This is what we predicted. The fifth person had diabetes. So these all corresponding to all the entries, you can get to know whether the person will have diabetes or not, right? Now to further better validate our entire model, we'll make use of caret library so that we can further use confusion matrix. Now confusion matrix actually gives you a very clear picture of the difference between your predicted variables and the actual variables. And it also gives me the efficiency of my entire model, how efficient my model is, so that I can make any changes if I want at the right time. So these are my predicted output values, fine. And my diabetes test data set. So here you can see that the accuracy of the model is 78.81%. That is a very fair model actually. And further looking at where we actually lagged were the values of 24 and 26, because here the difference occurred between the actual and the predicted variables, right? There was the probability of having diabetes, but finally the outcome was the predicted value said no. So there was this difference, right? So 24 and 26 shows that gap due to which the error occurred actually. But anyways, 78.81 is a very decent accuracy level in ground reality. So that is all about random forest. I hope enjoyed learning this session and you found this session very useful for you. Thank you guys.
I hope you enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries and we will reply to them at the earliest. Do look out for more videos in our playlist and subscribe to our Edureka channel to learn more. Happy learning!